everyone, and welcome to part 4 of our motion activated series, where we are triggering a variety of components that are popular for prop makers using nothing but a PIR sensor and an Arduino. No prop is complete without scary sound effects, so I have loaded up this MP3 player here with Halloween favorites, the classics. We are going to trigger sound effects. In reviewing our PIR sensor connections, if you have trouble seeing them, you can always pop this little cap off here. You can see our VCC, our output, and our ground. And then we have our knobs here. We have our time delay knob, where if you turn it completely counterclockwise, it keeps the signal high for the least amount of time. It's usually like 3-ish seconds. Or you can turn it completely clockwise to increase that time delay, where it'll be around 10-ish minutes, 7 minutes. It really depends on the model of your PIR sensor. Then you have your sensitivity knob, and we're not really going to be messing with this knob very much. Basically, it sets how far the PIR sensor can sense. So anywhere from 3 meters to 7 meters, we have it set all the way counterclockwise, so it senses the shortest distance. I'm like right here, it doesn't have to go far. Finally, we have our jumper. We have ours set in the L position. And that means single trigger. So say I have the timer set for 2 minutes. If I walk by, it's going to lock it in the high position for 2 minutes. So no matter what I do, it is locked out. Then if we move it to the H position, just by doing this right there, then that puts it into repeat trigger mode. So that means that if I walk by, the 2-minute countdown begins. I walk by again within that countdown, the 2-minute countdown starts over, and it keeps starting over again so long as it senses motion within that 2 minutes. So that's a great mode if, say, you have a bathroom light that you'd like to keep on so long as it senses motion. I'm going to go ahead and keep this in the L position, and we can rock through a couple examples. The first thing I'm going to do, because we are doing 2 components to the Arduino, is set up a master power and ground to the breadboard. I'm going to go over here like that, and I'm going to connect this to the 5-volt power of the Arduino. This can be powered right off of the Arduino, so can our MP3 player. Since I only have one 5-volt pin, well, I can't kind of jam 2 of them in there. So I'm going to connect them all over here, and they'll suck the 5 volts from the Arduino through that wire there. And I'm going to similarly do the same with the ground. I'm going to stick the ground up in here. And so now we have both ground and power powering this entire rail of the board. And we have our power for the PIR sensor. So I'm going to go ahead and hook him up to the power rail here. And the ground, the black, I'm going to hook up to the black. And it's going to get its power and ground from the Arduino. And then we have our signal wire. This is the wire that's going to tell the Arduino, am I sensing motion or am I sensing a whole bunch of nothing? Let's put this into pin 12. That's the pin we've been using, and heck, we've been pretty lucky so far. And now let's hook up this little module here. We know that very first pin is going to be our 5 volts. This is what's going to power our DF Player Mini. Then the RX. This is where it's going to receive information from the Arduino. The TX is going to transmit stuff to the Arduino. And we're going to skip over the DAX. Speaker 1 is going to be where you plug in the positive of your speaker. Then we have our ground. And then speaker 2 is the negative for our speaker. So that whole side pretty much takes care of what we want to do. Of course, on the other side, there are way more features that we can tap into, but that is for another live workshop. All right, back to the wiring. I'm going to stick this here. And this is, I guess I'll stretch him over here. He's reaching for that power. Let's then do our speaker here. And that was the 3rd pin from the last. And then the ground pin is the last pin. And then the pin right in between that is a ground. Basically, the speaker wires, they sandwich that ground wire. And finally, we have only 2 connections left, the RX and the TX. And this is where it gets a little bit confusing. So I'm going to go from the RX. of the player. And remember, the Arduino Uno only has one serial port here. So if this needs to receive, well, that means that this needs to be plugged in to the TX, transmit. And same thing with the next pin, which is our TX. This pin is going to transmit from the component. And if this is transmitting, well, then it needs to go into the receiving of the Arduino. We are all hooked up, but because the Arduino Uno only has the one serial port, that presents a slight challenge. Arduino can be very evil sometimes. It's like, oh, I'm so beginner friendly. Are you? I mean, really, are you? This and these ports are tied together, and there's no ifs, ands, or buts around this one. It's trying to send the Arduino the code, but there's stuff plugged into the ports where it needs to use. Before you upload your code, you have to remember to unplug these, upload your code, then re-plug them back again. This also means that you cannot use your serial monitor to monitor other things. Like say you want to monitor the status of the PIR sensor, whether motion is detected or not, because now you got some stuff jammed in there and the transmissions between the two are going to start to fight each other. A better option for something like this where you want to use the serial monitor, but you also need to use serial communication is not to do it via the hardware ports, but to do it in the software. So we're going to make one little change in our wiring. I'm going to pick pin number 2 to be our TX. So this is going from RX to pin number 2, which we're going to have to remember is going to be our TX. And then our transmission from the component will go into pin 3. So in the software, using a library called software serial, we're going to assign different pins to act as our serial transmission pins. If you're finding that your sound quality is like a little bit harsh, you can also add a 1K ohm resistor to the RX coming out of your component. And that little resistor there will help soften things up a bit. Let's go to the code, everybody. Probably a good idea to make sure that I hooked up the PIR sensor correctly and that it is indeed working. We'll get to the MP3 player here in a second. Let's set up our variables for our pins. So our PIR pin is attached to 12. Yeah, our lucky number 12. Well, we need a way to track what the motion status is. Is it currently high or is it currently low? So we'll call it motion status, because that's what came out of my mouth. And we're going to set that to 0 for now. And now we also want to track the state change. So sometimes we just want to know, let me know when it's high, and then don't let me know nothing until it goes low. Let's go like PIR state. And let's also set that to 0. You can, conversely set it to low. Low and 0 are pretty interchangeable. Let's set up the pin mode of our PIR pin. And we want to set it to an input because it is going to be gathering information for the Arduino. And then we're going to use that information to listen to some Halloween sounds. Let's set up our serial monitor as well. So serial.begin, we're going to use our good old 9600. For our loop, well, the first thing we're going to do is get the motion status. Like, is this thing high or is it low? And we're going to do that by digital reading our PIR pin. Now that it's read the PIR pin or PIR pin, we need to do something with that information. So if the motion status is equal to high, what do we want to do? So here's one place where you can activate components. So long as that PIR pin is reading high and it's going to keep rereading multiple times a second, it's going to keep repeating whatever motion or code that you put in this bracket. And I'll show you option 2. So here, if the PIR state is equal to low, what do we want to happen? So here, the motion status is the current status of the pin, which is going to be read multiple times a second. And so if the state of the PIR is low, which it will be because we set it low right here. So of course it's going to be low. So whatever I put in these brackets is going to get executed. So we want to serial print the fact that motion detected. And we also want to flip that PIR state into high. The pin's going to read whatever it's going to read, but this is a way to make a singular change in our code. So when the PIR pin goes high, this is kind of a label, and the label changes to high, and it changes to high one time until it goes low. The pin goes low, then it'll change back to low. Here is another great option. It's the option we actually use the most to put things that you want to activate. And the reason being is that it activates it one time. You don't want your skeleton to be like, welcome victims, welcome victims, welcome victims. That's what would happen if you put the code up here. What if there's no motion? So, or else, if there is no motion, well, what do we want to happen? Here is option 1 for deactivating components. We want to flip our label as well. So if the PIR state is equal to high, which will be true because it was high, we flipped it high over here. Now the motion, the pin has gone low. And so now we also need to flip our label. But before we flip our label, let's go ahead and print to the serial monitor that the motion has ended. And now we flip our label to low. And this is another great option area here, option 2 for deactivating things, because it'll deactivate it one time because it's kind of following this label flip, and the label flips only one time per state change. Serial print. Now, if you just put serial print, it'll keep printing on the same line. If you put serial print ln or serial print line, it'll say, hey, print this thing and then go to the next line. So let me make sure, oh, I did the same thing here, print line. There we go. The other thing I forgot to do, which is like super important, is most sensors need time to calibrate. So if you just don't give it a pause moment before it's ready to start working, your prop or whatever you have it hooked up to can go kind of like crazy. So it's always a good idea not only to zero things out, but in the setup, I always like to put a delay for the sensor, which means pause everything before we get into the loop. 30 to 60 seconds for this particular sensor is good. Now, I don't want to be waiting around for like a whole minute before we start our examples. So I'm going to go ahead and pause this for, I don't know, 3 seconds? Yeah, that's pretty good. We'll do 3 seconds. It's enough time for me to get to the table and start waving my hand around like a crazy lady. We have confirmed that our PIR sensor is working. For the Robot Player Mini, we're going to need a library for it. Now, this library does not come default with the Arduino. You can always download libraries by going to Manage Libraries, and you can start typing it in here. So here it is. And you can see that I have it installed. We're also using software serial. We have to use a library for that as well. So let's include that. And that is included with your Arduino. So it's right here. Let's put that, and let's scrunch up the spaces here. So we have all of our libraries, and that's going to allow us to assign different pins to use for our serial communications. And let's set up a couple more pins. So we have our PIR pin. So the RX pin that we have coming from the component is going into number 2, which needs to be the TX pin. So this is going to be 3. And then the TX, this is where the confusion happens. This is like half the battle right here. Many libraries, you have to set up a couple objects. Let's do software serial. And because we're setting up our own software serial, we have to give it a name. You can call it anything you want, but sometimes you end up setting up a lot of different serial ports, especially when you're working with the bigger boards. So I try and relate it to the component that's using it. So I'm going to call it effects serial. That's our like sound effects, right? That sounds kind of cool, like effects serial. And what pins are we using for that? We're using the RX pin and TX pin. Now, you can also put hard numbers here. You can put pin 3 and pin 2. The problem is your project is always going to evolve. And so that's why I like to set up my pins up here. So if ever I have to change them, I can only just change them up here and it kind of gets reflected up here. So we've set up our FX serial. We told it exactly which pins to use for transmission and receiving. We have to do the same thing for our player. Let's come up with the most longest name for our product. So I'm going to call this FX player. Anytime we refer to the serial, we're going to call it FX serial. Anytime we refer to our little MP3 module, it has its own unique name now. We'll go to the setup and do a couple different things. The pin mode of the RX pin, it's going to receive. That's got to be an input. And then the pin mode of the TX pin, well, that's going to transmit. So that's got to be an output. We have our serial for our regular serial monitor initialized. Well, we have to initialize the serial situation that we're using for our MP3 player as well. So FX serial, because that's what we called it, and begin. And we're also going to use 9600 for that. Let's do a couple things with the player. Our FX player. Let's set the volume of it to 30. You can go 10 to 30, 30 being loudest. I don't know how well you guys are going to be able to hear it, so I'm going to go like super loud. So one thing I forgot here is that we started our serial. We started our FX serial, but we never assigned FX serial to FX player. So the player doesn't know what the heck serial to use. FX player dot begin FX serial. We are initializing our FX serial and we're telling it to use a baud rate of 96. But then here we tell the FX player to use the FX serial. You know, don't be using this serial here, but be using the FX serial. We're going to pretty much be working here with option 2. And so if it senses motion, what do we want it to do? Let's get it to play something cool, right? So let's do FX player play. And which one do we want it to play? We can play the Chucky one. That's always a classic. And we want it to play for 5 seconds. And of course, if there is no motion, well, we're not really telling it to do anything. It doesn't have anything to play.
Hi, I'm Chucky, and I'm your friend to the end.
And then we need like stabbing motions. What if we wanted to play one thing when there is motion and then play something else when there's no motion? So I'm going to go into option 2 here. So when there is no motion, we want the effects player to play. I think the howling was number 2. And maybe instead of Chucky, we'll put, I don't remember what sound effect number 4 was.
Here there be pirates.
And then when the motion stops, the wolf howls. What if every time the PIR sensor goes high, it picks the next thing? So a lot of the toys that you squeeze, like, hello, be my best friend. And you already know where this is going. Like, this is a Chucky doll. Take it home, burn it, bury it, do what you got to do. So let's see if we can get it to sequentially play different things. When there's no motion, I'm going to have it do nothing. So how would we do that? Kind of get rid of some of this stuff. Ooh, we're going to need more variables, I think. Why don't we go up here and we'll come here. We'll call it track, right? And why don't we start it at track 1, which is our Chucky doll. If the PIR state now goes high, we want it to say our Chucky situation. So we're going to go ahead and have the FX player play track. And we specified track already right from the get-go as number 1. So theoretically, it should play the Chucky track. And how long do we want it to play the Chucky track for? Well, 5 seconds. And here is where there's other ways to do this, but to keep this very simple, most Halloween sound effects are going to be like 5 seconds or less. So using one delay to play all of them works. Now, if you're trying to cycle through like a 3-minute song and then other sound effects that are only a couple seconds, well, then people are going to have to wait 3 minutes before the next sound effect, a really short sound effect. So this may not make sense. This is definitely very useful for fun, short sayings that the sayings are all kind of like the same length. So it's going to say our Chucky thing for 5 seconds. And then after that, we want to increase the track number for the next go around. And this is basically a fancy way of saying track equals track plus 1. So it's going to add 1 to the track, and then it's going to loop back up to the loop, and it's going to take another reading. And it's, if it's low, nothing's going to happen. And then if it's high, theoretically, it's going to put the number 2 in here because it added 1 to 1 equals 2. It's going to play it for 5 seconds. Now, of course, not all of our stuff is 5 seconds. Most of it is 3 seconds, but close enough. And then it'll come down here and add 1. So 1 plus 2 is 3. So 3, 4, 5. Ooh, and then it's going to try and add 1 to 5, and we don't have a track 6. We need to tell it to loop back to track 1 once it reaches track 5, or if it tries to go above track 5. So in this case, what do we want to do? So if the track tries to exceed track 5, well, we want to say to set it back to 1.
Hi,
Chucky?
I'm Chucky, and I'm your friend to the end.
I think the second one is the wolf. Okay. I forget what the third one is. Is it the zombie brains? The fourth one, I think, is the pirate.
Here there be pirates.
Arr, matey. And then 5 has got to be then the laughing witch. That's the one we're missing. Oh, but does it loop back to Chucky?
Hi, I'm Chucky, and I'm your friend to the end.
We got it to work. Every time motion is sensed, it plays the next one down the track. But say we want to randomize it. You never know what kind of message you're going to get. It's like fortune cookie prop. So let's go ahead and kind of delete all that. You can also embed or nest functions within functions. So there's a cool function called the random function. And what is the random function? You basically give it 2 values and it picks something in between those 2 values. So on the low end, it can choose 1. On the high end, we have 5 tracks. But with the random, that high limit, it takes whatever you put in there and it subtracts 1. So it'll only ever play tracks 1 through 4. So always remember to increase this by 1 of what you really have. So we have 5 tracks. I got to put the number 6 in there. So it'll pick any number from 1 to 5 and play that track. And again, our longest track is 5 seconds. So I'm going to keep this at 5 seconds. Oh, wow. I forgot a parentheses. So the parentheses got to match up. So these inner parentheses are together and these outer parentheses. So if that's the worst of, oh, I think we got way too many brackets. I'll take this bracket out. You're the lucky bracket to be eliminated. Okay, so at least it accepted it. And because we're doing this live, I got a whole bunch of wacky spaces going on. Because we use the random function, it is possible sometimes to get the same sound effect play back to back. I can't fault it for the classic Night of the Living Dead brains. Oh yes, 5 seconds. The witch?
Here there be pirates. Here there be pirates.
Oh, so it repeated that time. See, I'm trying to be too fast. I had a blast with you guys. These are shot live. So inevitably, there are more examples, more things that I watch after the fact. And I'm like, I can't believe I didn't include that. Oh my gosh. So definitely check the fuller tutorial. Link for that is going to be in the description. Join our community where you can watch and participate live, as well as our weekly community Zoom builds where we all bust out our projects. We see each other where we're getting stuck, help each other along. I'll see you guys next time. Bye.